This is my lab 3 on circuits. The purpose of this experiment is to use the principles of energy conservation and current observation to predict the behavior of circuits containing resistors in series and parallel using multimeters to measure the actual values of conventional current and potential differences in the circuits and examining the behavior of resistors and capacitors. So the results preview: for the 10 ohm bulb, the capacitor took 8 seconds to charge and 12 seconds to discharge. The 20 bulb took 11 seconds to charge and 15 seconds to discharge. And then the resistance for the 47 resistor was 48, and the resistance for the 100 resistor was 102. Some of the important fundamental principles: the node rule, which is the current flowing in is equal to the current flowing out. The loop rule: the sum of all electric potential differences is equal to 0. Ohm's law and capacitance. And the formulas for those are here. Series circuit overview. So we have the circuit and the 2 ammeters, the 2 resistors, and the 2 batteries. And you can see how I set that up on the site in accordance to how the diagram is set up. Some of the calculations: the total voltage is 3 volts. The total resistance is 147 ohms. And so the current is 0.0204 amps. And then for the resistance calculations, we had 48 ohms for the 47 ohm resistor and then 102 ohms for the 100 ohm resistor. And then the wire and the ammeter is 0 and 0 for both of those because, yeah, their voltage is 0, so they don't have any resistance. Then here is a graph of the series circuit. Essentially, it's a little bit different than maybe what some of the other graphs look like, mainly because the current, the the ammeter is on top instead of on the bottom, so that sort of affects what the graph looks like. And then, but it should be same sort of concept, just slightly flipped lines. Then the resistance calculations and the parallel ammeter. So these again are the resistance calculations, and then it also just, I showed what, when you have the parallel ammeter, how the current changes. So it changed from before it was at 0.02 amps, and then now it's at 0.06 amps. Okay, moving on to the RC circuit overview. So the initial conditions are the capacitor, the bulbs, the battery system is the circuit, surroundings everything else, and you can see a picture of how I set this up. And then for the 10 ohm bulb, the capacitor took 8 seconds to charge and 12 seconds to discharge, whereas the 20 ohm bulb's capacitor took 11 seconds to charge and 15 seconds to charge. So it took more time, but the bulb was not as bright as the 10 ohm bulb. That was an observation that I made that I found interesting. And then here is a video that shows a graph of what's happening when the discharge of the bulb. So you can see how the graph sort of starts out steeper and then it gets less and less steep as the time goes on for that 20 seconds and until it stops and the capacitor is depleted. And then possible sources of error and what if. There Was human error potentially in the setup of the online platform? This is not a physical experiment, so there's not really much in the physical that could be an error, but there could be something with the online platform. And then these are my explanations of the what if.